Question 4 asks how many grams of carbon dioxide are produced by the combustion of 100 grams of pentane. In order to answer this question, we need the balanced chemical equation. This time we're starting with 100 grams of pentane. And we're asking how many grams of carbon dioxide. We need a connection between pentane and carbon dioxide. That connection is provided by the coefficients in the balanced chemical equation. 1 mole of pentane will produce 5 moles of carbon dioxide. And remember, this is the heart of our stoichiometry problem, the mole-to-mole conversion. We notice in this problem, though, that we need to make additional connections. We're not starting with moles of pentane, we're starting with grams. So we need to make a connection between grams of pentane and moles of pentane. This connection is provided by the molar mass. 1 mole of pentane is 72.15 grams. This number is obtained by adding 5 moles of carbon and 12 moles of hydrogen from the periodic table. We need an additional connection between moles of carbon dioxide and grams of carbon dioxide. Once again, we go to the periodic table to find the molar mass of carbon and oxygen. Adding those in the appropriate ratio gives us 1 mole of carbon dioxide weighs 44.01 grams. Now we have a complete strategy for solving this question. We'll start with the 100 grams of pentane. Convert that to moles of pentane. Using the molar mass. Our next step is to convert moles of pentane to moles of carbon dioxide. And finally, we'll convert moles of carbon dioxide to grams of carbon dioxide. Doing this on our calculator, we get an answer of 304.9996 grams of carbon dioxide. We notice, however, that we should only have 3 significant figures, so we'll round this to 305 grams of carbon dioxide. Question 5 asks how many grams of carbon dioxide are produced by the combustion of 25 milliliters of pentane, given that the density of pentane is 0.63 grams per milliliter. Again, we need to start with a balanced chemical equation. We're starting with 25 milliliters of pentane. And we're asking about the grams of CO2. The connection between these two is provided by the balanced chemical equation. 1 mole of pentane will make 5 moles of CO2. What additional connections do we need in this problem? We need to get from milliliters of pentane to moles of pentane. We see that we're given the density of pentane in the problem, so we can get from milliliters of pentane to grams of pentane using the density. Further, we can get to from grams of pentane to moles of pentane using the molar mass of pentane. As we saw in the previous problem, 1 mole of pentane weighs 72.15 grams. We'll also need the conversion between moles and grams of carbon dioxide. Now we have the full strategy to solve this problem. We'll start with the 25 milliliters of pentane. Use the density to convert that to grams of pentane. Convert grams of pentane to moles of pentane. Convert moles of pentane to moles of carbon dioxide. And finally, moles of carbon dioxide to grams of carbon dioxide. Checking the units, we see milliliters of pentane will cancel, grams of pentane will cancel, moles of pentane will cancel, moles of carbon dioxide will cancel, and finally gives us grams of carbon dioxide. Our calculator tells us that we have 48.0359 grams of carbon dioxide. We want to report this to 3 significant figures, so we'll round this to 48.0 grams of carbon dioxide.